you will learn about soil. Soil is the thin layer of matter that covers the Earth's surface. The type of soil available in an area is determined to a large extent by the landforms in that area. Consider the example of the river Huanghe, which flows through China. This river is also called the Yellow River, due to the yellow-colored soil it carries along with its water. The soil originates from the loose plateau in that area, which is covered by the same yellow soil. What is soil made up of? Soil is made up of organic matter, minerals, and weathered rocks. Weathered rocks are a result of the breakdown and decay of rocks by changes in temperature, frost, and actions of living organisms. This process is very slow and is called weathering. So slow that it takes hundreds of years for just 1 centimeter of soil to form. During weathering, rock debris gets mixed with organic matter and minerals, which help to increase the fertility of the soil. Thus, when minerals and organic matter are present in the right proportions, the soil is said to be fertile. Fertile soil is capable of giving life to and supporting the growth of plants. There are a number of factors that affect the physical and chemical properties of soil in a landform. The primary factors are parent rock and climate in the area. The parent rock, or the rock from which the soil is formed, influences its color, texture, chemical properties, mineral content, and permeability. For example, the black soil that we find in the Deccan region in South India is black in color, sticky, and rich in calcium carbonate, lime, and magnesium. It is known for its water-holding capacity. All these properties can be attributed to basalt, the parent rock from which this type of soil is formed. The second factor that determines soil formation is climate. Climatic conditions like temperature and rainfall determine the rate of weathering and the formation of humus. For example, the soil in the Deccan Plateau region in India is mostly made up from lava flows and is sticky. Since that region is very hot, the soil tends to develop long cracks. This helps to ventilate the soil. Apart from parent rock and climatic conditions, the other factors that affect soil formation are relief, flora, fauna, and microorganisms, and time. Let's look at how relief or The altitude and slope of an area affect the accumulation of soil. Steep slopes are more prone to soil erosion. So, the layer of soil on them may not be very thick. Low-lying, flat areas retain the layers of sediments for longer periods and thus have a thick layer of soil. Living or organic matter like plants, animals, and microorganisms influence the rate of humus formation. Humus is the degraded organic material in soil and helps increase its fertility. Dead plants fall on the surface of the soil and decay. The process of decomposition is helped by microorganisms that break down the organic matter when they feed on it. Animals such as the earthworm leave their excreta in the soil, which helps to make the humus richer. We talked about physical and chemical properties of soil as well as its fertility. But how about the thickness of the soil profile? A vertical section that shows different layers of soil is called a soil profile. The thickness of the soil profile is affected by the time taken for the soil to form. Here is a diagrammatic representation of a typical soil profile. Older soil has a thicker soil profile, as over time several layers of soil have been deposited and formed. However, due to the introduction of other matter in the soil over time, older soil retains relatively fewer characteristics of the parent rock. All of these factors together result in the formation of different types of soil. The types of soil found in India include alluvial, black, red, laterite, desert, and montane soil. Like land degradation, soil degradation is also an area of concern. This degradation is caused by activities of human beings as well as some natural activities. The two greatest threats to soil come from soil erosion and depletion. Soil erosion occurs when soil and rock particles are carried away by wind, water or ice, and deposited in another location. Soil depletion takes place when the nutrients in soil are removed and are not replaced. It affects the quality and fertility of the soil. Soil degradation is caused by deforestation, overgrazing, excessive use of chemical fertilizers and pesticides, rainwash, landslides, and floods. For example, one of the main reasons for the lack of fertile soil in Afghanistan is overgrazing. In Iran, trees were cut down for timber and fuel and were not replaced. This has led to widespread degradation of soil. How can we prevent soil degradation and conserve soil quality? Some methods to conserve soil quality are mulching, contour barriers, rock dams, terrace farming, intercropping, contour ploughing, shelter belts. Let's look at these methods one by one. Mulching helps to trap moisture in the soil and moderate soil temperature. It involves covering the bare ground between plants with a layer of organic material like straw. Mulching is widely used in dry regions like Arizona, USA. Contour barriers refer to barriers of stone, grass, and soil built along the contour lines of a slope. Trenches are built in front of the barriers to collect water and prevent it from flowing down the contours and washing away the soil. Many farmers in northern Thailand have used this method to conserve soil, as the area has steep slopes that are prone to soil erosion. Rock dams are dams created from piles of rocks that are stacked up to slow down the flow of water and prevent the formation of gullies. This curtails soil erosion. Rock dams are being extensively used as a soil conservation measure in the Andaman and Nicobar Islands in India. To provide flat surfaces for farming on steep slopes, terraces are created. This is called terrace farming. Using terraces also prevents soil erosion and surface runoff. If you go to hill stations like Darjeeling, you will see that terrace farming is widely practiced there. Intercropping is a widely used practice in China to reduce soil erosion due to rainwash. In this method, different crops are grown in alternate rows and are sown at different times. Contour ploughing is the method of soil conservation in which the land is ploughed parallel to the contours of a slope. This creates a barrier that prevents water from flowing down the slope. Contour ploughing has been used to prevent soil erosion in the prairie regions in the USA. In coastal and dry areas, rows of trees are planted to control the movement of wind, thus protecting the soil from being blown away. These rows of trees act as shelter belts. Shelter belts can be seen in areas that are prone to fast winds, like the coastal regions of Orissa in India. As we reach the end of this module, try this activity to see how planting trees prevents soil erosion. Take 2 trays of the same size. At the end of each tray, make 6 small holes. Next, Fill each tray with the same amount of soil. Leave one tray as it is. Plant grass in the other tray. Wait for a few days till the grass has grown at least a few centimeters. Hold the first tray, which has just the soil, at an angle so that it forms a slope. Pour a mug of water from a height onto the tray. Make sure you collect the water that drips from the holes of the tray in a container. Repeat the same action for the tray with the grass. You will see that the water that you collected from the first tray is muddier than the water from the tray that has the grass. This proves that planting trees can help in preventing soil erosion.